During the early stage of system development, it's not uncommon to use prototype board and jumper cables to interface various components to create an embedded system. Such system or system prototype provides an easy access for the user to conduct quick modification and troubleshooting of the circuitry. The disadvantage is its bulkiness, which makes it difficult to be fit inside a compact system. To solve this problem, we can design and fabricate a printed circuit board, so-called PCB, to facilitate all the required components used for the embedded system. There are many free software out there such as Autodesk Eagle, KiCad, Design Spark, and Fritzing, etc. Among them, Design Spark is probably the easiest for beginners to learn. Today, we are going to explore some of the features that Design Spark provides for us in constructing the schematic and PCB layout of a circuit. Once you have downloaded and installed the Design Spark PCB software, you can launch it from your desktop. A pop-up window will appear right after the software is opened. This window shows you the latest update or news related to the software and its user community. We can put this on the side for now. Before we jump into creating a new file or project, we want to first configure the library setting. Libraries allow us to utilize all the pre-existing component symbols of the schematic and the component footprints of the PCB layout. Here, we should add the three subfolders, Default, Pickaxe, and User, to the Library Manager. Make sure these folders and files are all enabled as shown by the check marks in the enabled boxes. Next, we are going to create a new design by going to File, New. There are three options for us to choose from. We can start by creating only a schematic diagram, or only a PCB layout. Or a project that encapsulates both the schematic and PCB layout. Project allows the user to import multiple files of schematic diagram and PCB layout to its folder so to make the work more organized. We can create a project here by specifying a folder location. We can now create a new schematic file in the project folder. This blank white screen is the workspace of the schematic, and you can see the file is placed inside the project folder here. Let us create a simple LED circuit as an example. On the schematic workspace, we select Add Component. We can select any components here that are included in the libraries. For components that are excluded from the libraries, we can download them from other third-party resources. And I will show you how to do it in the next episode. Let's begin by adding a voltage source of 5 volts here. After you have placed the symbol on the workspace, you can press the Escape key to complete the action. If you want to rotate the symbol, you can click on it and press the letter or key once to rotate it by 90 degrees counterclockwise. If you want to rotate it in the clockwise direction, you can hold down the alternate key, then press the letter or key to do so. Now, let's go find a LED and add it to the circuit. We can type the component name in the search box of the Find window to locate the component. I will use the LED that comes with the Design Spark library here. We will also need to add a resistor to the circuit to limit the current going through the LED as an overcurrent protection. We will use a 1 kilo ohm resistor here. To connect each component together to form a circuit, we can simply double-click the node of one component, then drag the line towards the node of the second component. When the line connection is done, double-click the end node to complete the action. When the connection is successfully done, you should not see the cross mark appeared on each node. Next, we are going to add a ground to complete the circuit. Lastly, we want to add a connector to supply the voltage and the ground to the circuit. To do so, we will add a 2-pin connector to the circuit. Use pad A of the connector as the voltage source and pad B as the ground. To connect a line segment to an existing line to form a joint, we can simply click on the existing line once. Now the schematic is completed. Meanwhile, I would like to show you a very useful tool called Interaction Bar. This feature allows the user to find and inspect individual items in the circuit such as component, connection network, pad, grouped item, etc. We can use this feature to easily locate an item on the schematic. If we want to locate the resistor R1 and modify its resistance value, we can do so by choosing the component filter and select R1. The resistor will then be highlighted on the schematic. Double-click the symbol and go into the Properties window. You can now edit the resistance value there. As an alternative, you can also pull out the component values in a tabulated format by going into Settings, Component Values. You can conveniently edit the value of every single component on this table. If you want to check the connectivity of each connection network, such as the voltage connection, ground connection, and the connection network between components, we can go to the Net filter to inspect each of these networks. If you are happy with your schematic design, you can go ahead to translate it to a PCB layout. To do so, we go to Tools, Translate to PCB. You can specify the measurement unit and precision here. Then, specify the number of layers you want for your PCB. The more the layers, the higher the complexity of the circuit, and the smaller the area the PCB occupies. If you are new to PCB design, I recommend you to use up to the 2-layer format. Next, specify the paste mask and solder mask if they are required on your PCB. Paste mask is used during the PCB manufacturing process when the components, particularly surface mount components, are soldered onto the pads on the board. The paste mask outlines the area where the solder paste will be applied on each pad. You have to include this feature if your components are required to be soldered onto the PCB during the manufacturing process. If you plan to solder the components manually by yourself, you may skip this step. Solder mask, on the other hand, is a thin layer of polymer that is applied to the copper traces of a PCB for protection against oxidation and prevent solder bridges from forming between solder pads that may cause short-circuiting. It's always a good idea to apply solder mask on your PCB regardless if your components will be manually soldered or not. If your PCB is a 2-layer board, you may want to apply the solder mask to both top and bottom sides. We will also apply the solder mask onto the vias for extra protection. I will spend more time to talk about vias in the next video. We now define the shape and size of the PCB here. We can choose either the rectangular or the circular shape. Define the dimensions of the board using the input boxes here. Use the default setting to leave the components outside of the perimeter of the board, so we can arrange the location of each component manually. Next, you will see a PCB file is being generated by the software based on your schematic diagram. There is a pop-up window showing the status of your PCB file. As long as there is no error message appeared in the report, you can close the window. The green box here is the perimeter of the PCB. We can place the components inside the green box and space out the components nicely. The thin yellow lines here represent the connections between components. Again, you can use the interaction bar on the right to locate or inspect each component or network on the PCB. Go into each network and specify the type of connection associated with each one. There are three typical types of network: power supply, signal, and ground. Each one of these networks may require different current rating for the application. Therefore, it's better to define and categorize them at first. The maximum current that can be carried on each copper track on the PCB depends on the width of the track. You can use the table here as a reference. Say, if our LED consumes 600 milliamps of current continuously, then we should use a track width of 0.3 millimeters. For a simple circuit like this, we can use a feature called Autoroute nets to complete all the connection networks on the PCB. Simply go to Tools, Autoroute Nets, and select All Nets. On the pop-up menu, enable miter track, and then select any angle for the miter setting. The miter track option helps to eliminate tracks that contain acute or right angles. Tracks with acute and right angles can reduce the signal quality of the circuit, so we should try to use a curved track or a combination of obtuse angled tracks to replace them. And we should also keep the number of vias, bias, and side pad exit to a minimum to reduce resistance and noise. Now press the Route button. The software will automatically generate all the connections on the PCB for you. If it is successfully done, you will see a pop-up message saying the connections are 100% completed. To view the 3D model of this circuit board, you can go to 3D from the top and select 3D view. Now you can see how the PCB will look like in reality. Do you see anything wrong with this circuit board? Is this a completed PCB? We will discuss about these in the next video.